Okay, welcome back. So yesterday we took a very quick look at homework number 6, and we looked at what you do with dividing with decimals, but we didn't touch on the hardest part of it, which is what do you do when you're dividing with decimals and then you come up with the remainder at the end, because obviously you can't keep a remainder, because a remainder in a division problem is just like a part of a number. It's not a whole number, it's something less than the whole number. And a decimal is less than a whole number, so you can't have like two of the same thing. You can't have 52.3 remainder 3. That doesn't make any sense. So you've got to do something with that remainder, and this is what today's lesson is going to teach you. I'm going to show it to you in two different ways. One is kind of the old-fashioned algorithm, and the other is the box method. Now, both of them have their pros and cons. The algorithm is easier to use. It kind of puts the decimal in the correct spot right from the beginning, but the rest of the math you have to get perfect every time. The box method is a little bit wonky with the decimal, so the decimal is a little funky. You got to learn a little pattern with that, but it goes along with box method of division and multiplication. It's just base 10. The actual math work is much easier, so you're going to have to make a choice. Do you like getting the decimal, nailing it correctly right from the beginning, but having the math a lot more structured? Or do you like having the decimal kind of figuring it out at the end, but having the math powers of 10? That's going to be your choice. I'll show you both ways today. Okay, so let's get started. We're going to do the same problem 2 times. So 207 and 9/10 divided by 6. We're going to do the exact same problem twice, so you can see the similarities and differences between these two methods. First, I'll do it kind of the old-fashioned algorithms type of way. This is where it's easier with the decimal. The decimal starts here, and it goes right to there, so very simple, very easy. Then you ask yourself your mathematical questions. Is 6 times anything going to 2? No. Actually, I've been having the kids draw what I call boxes and bars. Keep your math nice and neat. 20, yeah, it goes into 20 3 times, which would be 18. I'm going to subtract. Got a 2 left over. Bring down the 7. Alright. Does 6 go into 27? Yeah, I would say the closest would be 4, which would be 24. Subtract, we got 3. Now we have a 39. Now, does 6 go into 39? Yeah, we'll say the closest is 6, which is 6 times 6 is 36. 3. So now we finally got to a point where we're going to have a remainder, 6, remainder 3. But we can't do that because, as we discussed, a decimal is part of a whole number, and so we can't have a remainder and a decimal. So what we just have to do is we're going to add a 0. And bring that guy down. It just says like a placeholder. It didn't change the value of this number at all. It just added a place to it. And then we know 6 times 5 is 30. And that gives us our answer, 34 and 65 hundredths. Not too bad, and actually this method was quite easy this way. Let me show it to you the box method way. Same problem. Box method. So as discussed yesterday, we figure this decimal has 1 power of 10. So what we'll do is pretend it doesn't even exist. Just pretend it's not even there. And up here in my parking lot, I'm going to put a 1. 1 power of 10. We have to remember that. That's where I was telling you this method is a little bit wonky. Where this method starts with the decimal in the right place, ends with the decimal in the right place. This one you kind of got to get rid of the decimal and do some tricky things with the decimal. The rest of the math, in my opinion, is easier though. This goes back to our box method. 6 going to 20. We'll do 3 because we already know the answer is going to be 34.65. But this method, you don't have to get the number right. You could have gone with 2, and then you could have done another. You could keep going. So 6 times 3 is 18. 6 times 300 is 1800. We subtract. 279. You could definitely see the similarities, like when I subtracted here, I've got the 27, and here's my 9. And when I subtracted here, I got a 27, and here's the 9. The 6 go into 27. Yeah, the same as the other one. We want 4. Not 2. 4. And we knew 6 times 4 was 24, so 6 times 40 was 240. 9. We have a 39. Starting to see some patterns. We got a 300, we got a 40, we got the 3, we got the 4. We have a 39. And we know that 6 times 6 is 36. And we have a 3. Just like the last problem, we can't have a remainder 3. So in this case, I'm going to give it a 0. I'm going to make a 30, and I'll add a decimal. This is where I told you it's a little bit trickier. You added your own decimal here because now I have a 30. And 6 times 5 is 30. So what I end up is 346 5/10. Now all you have to do in this method is remember that you have your parking lot way over here with the 1. So 346 5/10, you move it over 1, you've got 34 65/100ths, which is the same that you got over here, 34 65/100ths. Your choice, whichever method you like the best. Just remember, no remainders.